So hello again, my name is Alexey, and today we talk about Cucumber JS support in Rapise. This is me, and you see me, I believe you know me, many of you already know me. We talk about newly added feature, it's Leaped Cucumber, that enables use of Cucumber JS within Rapise tests. This leap is now possible because we enabled Node.js support in Rapise since last version 6.7, and Cucumber.js is based on Node.js. So now we were able to combine them together and use the best from two worlds. Just for those who maybe didn't use Bdd so far, in Bdd, behavior-driven development approach, we describe the application behavior using so-called feature files, and you see one of such features on the screen. The feature describes high-level behavior of some application aspect, as well as some usage scenarios, simple usage scenarios where we tell what we have in the beginning, what we do, and what we expect to get in the end, or what user expects to get in the end. And we will talk about this later, but first, when we learn something, or we research internet about BDD, behavioral development, we may find a lot of criticism as well as a lot of support to it. So there is sort of holy war situation when people do it. Some people accept it, some people don't accept it. And the article that the title that you see on the screen from the article, it's article from one of the Cucumber and Bdd creators. It's one of its initial authors who actually the target for the criticism, and he tries to explain that the criticism comes from incorrect usage of Bdd, which is unfortunately a very common situation. And starting from incorrect usage, and this leads to like disappointing results in the end. And in this article, you may see the link on the screen. In this article, you may learn why he explains what is the most common mistake. And to begin with, long story short, the most common mistake is that this whole approach is about designing before implementing anything. So the feature file, like you see currently on the screen, is supposed to be written by three amigos. We will talk about it later. It is business representative, it is developer, and it is QA or test person before doing anything, before application actually exists. So we describe application first, we write these features, and then these features are used by a developer. And it's expected that initial unit tests are created by developer to cover basic functionality, and then some more tests are created by QA or testing person to increase the coverage. But again, developer creates initial tests before application exists. This is a key concept. So when preparing for this particular webinar, for my first idea, so I understand why this mistake happens all the time. When I was preparing for this webinar, I was thinking about, okay, let me find some feature files, some common feature files for very common scenario. We have library information system application. We have library information system application. The first idea was, okay, we have a login screen here. I'm lazy to write these features. Let me find the most appropriate ones, because when you search for forums or for information in the internet about how to write proper feature files, how to use Gherkin language, whenever someone writes it, there are like 3 or 4 persons who will tell that it's wrong. It should be written different way. It breaks some of the concepts of the Gherkin. It should be designed differently from the BDD ideology point of view, and so on and so forth. And it's really hard to find like proper reference examples even for scenario like that. And then I realized that actually I'm going right to the trap, because we have an application. You see it on the screen, right? And now I'm trying to find some common feature files, the current application like this one. And this way, I'm actually breaking the concept, because application is already implemented and I'm going to add feature files for it. And it's fundamentally wrong approach from the BDD point of view. If application already exists, it's too late to start writing feature files. It's actually waste of time. You will not. You will probably go to the same trap as all those people who then complain about the BDD's guilty in inefficient testing that they get in the end, or testing results or testing impressions. So this is what we get. Now, that is why I'm going to follow the same path as I supposed to follow when I'm, if I use this approach in proper way. So I first have a scenario. Scenario is, it's a bit abstract, but that's good. It's something about eating the cucumbers. So you may see it on the screen. It's very trivial. And I want to implement it. Now I'm going to implement it, and first I will tell you that application does not exist yet, and that's typical, and that's good situation. So if application doesn't exist and I have a feature file, that's good. I'm on the right path. Okay, so I'm going to use a new Rapise library, and I'm going to begin with it. Now let me show you how you may do this. Opening Chrome, go into Inflectra GitHub, Rapise Power Pack. In Rapise Power Pack, there is a Cucumber section, and there are 3 parts in it. One is just libcucumber if you want to embed it in your existing testing framework, and this is sort of advanced usage. We won't follow it right now. And 2 other options is JavaScript-based template. This is if you want to develop your tests in JavaScript, and RL-based template. So we are going to try both options, JavaScript first, and then RL option. So I'm clicking on download link. I have this JS template downloaded. It should be here, and I'm unpacking it to the desktop. Go in there, opening. Okay, I have it here. So it's called now JS template. I want to save it with some different name. File, save as. It should go to my documents, my Rapise test folder, and it will be named either Bdd JS, for example. Wait a bit. The test is renamed and saved there. Now it's loaded, and in a bit, okay, it's shown on the screen. So now I have like preset template. This template contains one feature in the feature file, contains feature implementation in the JavaScript file inside step definition. So for those of you who are already familiar with Cucumber, you will find that it's like standard setup. For those who don't, I hope you will get an idea very soon. It's sort of standard thing. You just put your feature files one by one here and implementation files here. This is the most basic way to expand it. Also, this template contains a library itself, and when library is properly loaded, just a second, it should be loaded. I should have a Cucumber object here. Actually, everything is here. Okay, I got the point. Sorry, my bad. I forgot to add one important file to this library. That's why it's not showing the object. It should contain these 3 files. Then it works properly. This will be fixed in GitHub. I had problems with GitHub an hour ago. That's why I have a bit of mess on my side. I wasn't able to do something until GitHub recovered. I'm putting missing files here. Quick fix, you didn't see it. Okay, now going back to my test frame, my copied version of test framework. Adding missing files here. They should be here. Saving it and reloading the test. And if everything is okay, there is a Cucumber object. It's defined in the library. It has just one method, run. In addition to the feature files, to the library, there is a main file that can by default contains just one statement, Cucumber run, and wildcard to run all the features. We will probably fix it when we have the feature implemented. So once we follow the BDD path, we start from implementation of the test first. And for implementing the test, we need to have this feature, eating feature, and JavaScript file to put its implementation. So I'm going to, again, use this Reveal and Explore feature, just clone this template and rename it to eating. Go to step definition, clone, copy paste the template and rename it to eating.js. Now again, show files in files view and add this new feature file and the JavaScript file to the test files tree. Okay, I have a new feature, it's here, but it's a clone of default feature. Default feature simply contains instructions on how to use template and how to clone it. I'm going to remove it and I'm going to copy the feature. This is simply the text that I have in my slide. So exactly the same. So this is the feature implementation that I have from the beginning, and I'm supposed to have a test for it. Now, when I have a feature, all I need to do, if I follow the Cucumber path, I just need to play it. But I don't want to play 2 features because in default setup, it would play both of them. And I don't want to play this template at all. So I want to specify that I only play this feature. Actually, the way to control which feature to execute may be this one. So you just specify them one by one, or you may split them in subfolder features, some features, and they use this wildcard functionality to have more fine-grained control of what features to execute. Currently, we have just one feature, and with Cucumber, default behavior is to just play it. So we have an error, and this is expected. And in output, we may see that the error is that the library cannot find the module Cucumber. We have a package file here. So for those of you who are familiar with Node.js, now that package JSON defines the files that are the libraries and npm modules that are needed for this particular module to run. So to apply this, I again need to go to the folder with my test, this one. I'm copying the folder path, starting the command prompt, go into that folder, and type in the command npm install. Install would take all instructions from this package.json and would deploy all missing Node npm packages that are required by the current one. And you see it has 108 additional packages installed. They all are here. So new folder Node modules shown up with hundreds or maybe thousands of files and additional things that are required for Node.js to properly run. Again, playing again. Just playing the test and checking what error we get now. So now it started execution, and the error is that some steps in the feature are undefined. And this is an expected behavior. So we, as it's a common thing for Cucumber that then something is missing, Cucumber suggests the template to be used for the implementation. And this is what we have right now. So this is a template JavaScript code that we need just to take and put to our JavaScript file. So it implements the feature steps. So given there are integer cucumbers and so on and so forth. So I'm going to just change this default naming. So it just uses type instead of parameter name, and I'm just want to use something more clear. So this is start or initial amount of cucumbers we have. Then we should have how much the cucumbers were ate by the human, and then how many we have left after that. So we may use the world concept. So this is sort of world. It's something shared between all these three implementation steps. And we may say that this start equals to start to assign some value. This maybe not start, amount or count. This count round equals this count minus 8. So how much is left? And here we just do the comparison, and I'm using Rapise methods for comparison. Assert equal. Expected number of cucumbers left, and this count left expected number equals to this count. So this is most trivial implementation, and we may just play it. And we see that feature now passes. It passes twice because this feature contains an example, and it gets executed for each row in this example data set. It's similar to our rail map feature, but implemented in Cucumber. Well, so but we have some template implementation. It's not it's not relevant to actual system. And we may still follow the BDD path and get closer to actual system. And we may do this. Suppose that system is yet supposed to be implemented, but we probably have some prototype that we may use to implement the initial version of the test. And in this particular case, we have a prototype. This online calculator may prototype the ether. So we type some number of cucumbers, many we initially have. Minus means how many cucumbers we eat. Minus, so we ate 4 cucumbers, and equals means how many are left after we ate. So we may just implement just this scenario, and it would be initial version that developer may use and actually start changing the system from this fake implementation to actual implementation. So I hit record, and I'm using the learn functionality. Remember that, again, system doesn't exist yet, so we have probably nothing to record. We have some prototype, we maybe probably learn some objects and write some initial interactions. So I'm going to learn this input section, and call it input. Then minus is, come on, minus control 2. So it's an eat action. Then equals means get how many cucumbers are left. Check how many left. And no, not clicking, because it's a prototype of application, so it's not working exactly as expected. It's a results section. So I have these 4 objects. This is enough to implement my scenario. Going back to Rapise, going to the feature implementation, and going to start. So I'm not going to hold these values inside this fake implementation. These now are values that will be accepted by the system and will be processed by the system prototype. So I am using the objects I've just learned, and first is input. And I'm going to first click on the input. Then I want to press escape key to clean the calculator. Do send keys. Escape keystroke, the standard combination for send keys. Then again, SS input. Do send keys and start. So send initial amount to the calculator. Then here I will press minus, which is eat in our situation. Click on the eat. And type send keys, type the number of eaten cucumbers. Finally, I press on check left, which is equals sign. And what I have to do, I have to compare this expected amount of left items with what I have in the results section of my calculator. So just using result, get text, for example, get inner text, get text here. Result, get text. That's it. So I have some implementation based on my system prototype. Playing it. still using all favorite features of Rapise when working with browser. We don't need to care about starting browser, about initial navigation. Okay, so it failed, and we see the reason for the failure, because 7 is not equal to this 7, to actual 7. It means that this output of the calculator contains some extra white spaces, and we need to trim them. We may easily do this using global do trim. Operation. And now if we play the same again, this time it should pass the test. Yeah, so it's finished with first row in the example data, and then it's passed for the second row. So we have it here. We may switch to hierarchical display. So we see that each feature is formed as a subtest with exact information here in the plus section. And we now may use all additional features of Rapise, collection of screenshots, saving it to Spira. So everything else is as usual. We may use test management from Spira test, and so on and so forth. So this was the basic implementation of JavaScript. It's so it works more or less end to end, except one thing that we don't like, that we cannot, it's hard to execute one part of the test or one section of the test without executing the rest. So it's more complicated. We may execute a part of the feature of this, or just the step of the feature using Cucumber, and we may even do this here, but it's not really a convenient way. So it's now time to show what we may get if we use RVL. So we go back to our implementation, download section, and download next part, which is RVL. Okay, we have this template. Closing JavaScript version in Rapise, opening RVL template. Just checking that we have metadata files properly included. Yeah, it's included here. So we're all set. Going to do save, closing start page. And doing file save as, save test as, and saving destination is documents, my Rapise test, and iter bdd rvl will be the name. Waiting for test and all assets to be saved. Okay, library is here. Cucumber object is here, so we're all set. Again, we have a template and we have a feature file that we want to clone before we start implementing the same, exactly the same template feature. Again, reveal and explore, copy paste, oops, rename it to eating. Go in here. So in RVL, we have two files. We have JavaScript and rvl.xlsx file. Okay, so we have everything prepared on the disk. We need to include it to the test now. We add in eating, we add in RVL, we add in the feature file, hiding the files on disk back and saving. So we prepared for execution. Let's see what we have in the feature file. It's again template feature. Let's use our feature here, paste it, close this notepad. Okay, we prepared for execution of this feature. Let's see what we have in main RL file. It would be the driver for execution. It contains the similar run statement, and it contains run for all features, but in RL we should better have this drop down. We may choose which feature to run. Again, we want to execute just one feature, it's eating. And just playing, getting this expected error that Cucumber is missing. Then doing reveal and explore, copying the folder path, running the command prompt, pasting. Now we do type npm install, waiting for our 108 packages to be installed. Okay, so Cucumber, 107, 108. Okay, everything is here, so node modules is here. And now the feature should be able to play. And next step is it should play and produce the template code that we will use in our implementation. Scrolling back, and between these equal section separators, we have it. So there is a template implementation going first to JavaScript, and we now may see that this JavaScript implementation contains some RL play section statement, and this hash prefix statement, it's expected to be put into the RL. In RL, everything starting from hash is a comment. So we are opening our RL, and we're going to put these hashed parts here to have placeholders where we are going to implement actual features or actual feature steps, I mean. Okay, this is done. This is here, and maybe last one will go here. Copying it, cutting it, and pasting here. Okay, all three sections are the section placeholders are now done. So this statement knows what to do. Now again, this naming is not good, and I need to change it with something more meaningful. So it was start, and here I pass this value to RL. I use this as a field name, and this is a field value. So most common syntax for passing it is this one. Just use all the input parameters one by one and pass them. So if we have a second parameter, we don't have it, but if we have it, we would pass it the same way, second. And for those of you who are familiar with JavaScript 6, we may skip using this part with a colon, but again, we prefer to use older syntax for now, which is proven to work. Now we have second parameter. It complains, it actually has a warnings here. It complains about using the int. For some versions of JavaScript, int is forbidden word. So we need to change it with something. So we have 8. How many cucumbers were 8 by user, by human? 8. And here we have how many left after. Okay. So we have these placeholders, and we have placeholders here. Now the question is how to pass this. So it's passing value start, 8, and left to this spreadsheet. But to receive these values, it should contain corresponding variable placeholders. And you may see that it contains the command that put all the placeholders here in the beginning. And this is important to reuse the preamble feature of REL. So I'm defining the variable start and assigning some default value. In REL, we prefer to always assign default values. Then variable how many 8. Suppose we ate 3 cucumbers, and here we have variable left number 7 minus 3 is 4. So this is default data set for this implementation. Okay, I can remove these hint statements to have. So now I have these 3 sections I'm supposed to implement. And long story short, I may just do the same learning session and learn the same objects with this calculator, assuming it's a prototype of my system, to have a working test. So I'll just do it right now very quickly. Let me click here, click escape, remove recorded. So I'm in initial state, and now I'm going to learn this input section, result section, minus and equals. And input is input, result is result, eat verb, and check left action. So that's it. These are our 4 objects. Now Rapise shows up, objects were recorded. So I'm supposed to go back to this and it's actual implementation. So doing it quickly, I'm going to use input object and do click on it, then send keys escape keystroke, then send actual number of items. It's a start variable start. So use the value of variable start as input to the input field. Now the when section. Here I'm supposed to press eat, click on eat, and then input the number of eaten cucumbers. Action, input, do send keys, variable 8. Finally, I supposed to click on check left. And just to show you the difference, I'm using the keyboard, but you may find it more useful to use this approach that just find an action and drag it here, check left, and then find input, find do send keys. Oops. Do send keys. And oh, we don't need do send keys. I'm wrong. We don't need to send it. We need to read. We need to read the text. We need to use get text here. We get text. We need to trim the text. So this is a global object. It has do trim action. Do trim. And input is variable last result. So output from this action will be passed to this action, and our last result will be trimmed and put back to the last result as a result. So now we need to compare this last result with expected number of left items. I may use tester, assert equal, check some message. First parameter is expected amount. It's a variable left, and then actual amount. It's variable last result. So now we're all set. We have 3 sections. We have a feature file, we have JavaScript file that calls RVL, and it's supposed to work now and go through our scenario using RVL. So 7, it looks like we didn't click on the equal sign. Oh no, we read result from the input rather than from the result. Let's see. We read it from input. We should use result here. And now it should work. Okay, I won't execute it again. So believe me, it works. I tried it before, so it works just with JavaScript version. Let's proceed to to some more theory. So we used exactly theoretical approach. We first used the JavaScript mode. It contains library, Cucumber library, and templates, feature, and JavaScript file that you'd expect it to copy paste and then fill with your features, and package JSON that is needed for npm install to install the Cucumber into your testing framework. In RVL mode, exactly the same, except that the templates contains both RVL and JavaScript, and the code that gets generated when you play the feature while it's not implemented produces a bit different JavaScript that is supposed to split between JavaScript and RVL parts. So we roughly follow this BDD process, and now it's time to, so this is like idealistic process. Now it's time to talk about like the reality. So it's expected that BDD used together with so-called three amigos approach, when before doing anything, 3 persons meet and talk about the system. So business person shows user view on the implementation. Developer adds known limitations, possible solutions, and so on. And they all together write these feature files. So the key concept of this feature file to be crystal clear for all three persons here. So, and QA talks from the testing perspective. So how it would, how testing scenario may looks like, how easily testable it would be, how reasonable it would be. So provide some exploratory or imaginary exploratory or expected results from the system. So they all together write these behavior files. So these may be used to make sure all of them have common understanding and all of them ready. So will be no surprises for anyone. So a business person knows what he will get, developer knows what to do, and QA knows what to test and what amount of things needs to be tested, and may prepare some testing scenarios and test plans in advance. So all 3 of them write these BDD features, and the development begins. What usually happens is that with time, business persons slowly switch into some other things, other priorities, and QA and dev work on these features together. And these feature files become more and more low level and specific, but they are still clear for these 2 actors, for dev and QA. So it may, for example, look like this one. It's some API test implementation. So it's already quite low level, and at this point, it's sometimes not. It goes away from the documentation perspective. And it becomes an internal specification. So it's less clear for like end user, but it's more clear for dev and test person. Then with time, the product comes to some mature stage, business is switching to some other priorities, has other things to do, is focusing on sales, focusing on something else. Dev is switching to support mode, where he usually or he or she receives urgent bugs and feature requests from business, and usually this feature comes directly in Skype, in Slack, in email, that something urgently need to be done to close some deal to implement these missing features, and the product finally goes to the feature goes already implemented to QA. There is no time to implement the test in advance, so it's implemented for already implemented feature. And finally, we end up that the only holder of the features and the only maintainer becomes this QA person. Developer is doing its own tasks, it's focusing on support, business is somewhere else, maybe switch to other project, and we finally, get specification like this. It contains, you see the lines like wait for 15 seconds, make sure the browser is open. So from the business endpoint, this whole scenario may be shortened to 3 lines. But since the test developer needs to have working and reliable test, this person is focusing on fixing them right here. So it's far away from the initial concept, from being source for documentation, source for common understanding, or some specifications. It's already a testing script. It's an automating testing script. And surprise is, this testing script is actually a bad testing script. So there are better ways to implement testing script. It's much easier to implement the script without all these steps, because when you have the feature files, you still have to implement this glue code. Then you need to implement actual implementation. You need to know how many actions do you have. So it's not really convenient, not effective way to have your tests. So with time, let me show you. So why I think RVL is really a great solution for such situation. So suppose that this eating scenario was implemented initially and it was perfect. It was fine, and the initial version of product was okay. And it was working. When with time, when business were away, when developer were actually working on other project, you got an urgent requirement. So, for example, medical research shown up that eating the health of the nation is a victim of the fact that you have to buy whole cucumbers, while you sometimes prefer to have half of cucumber or a part of cucumber. Otherwise, you have extra belly fat. Your health is injured. So the act shows that all the system dealing with cucumbers should allow you to buy a part of cucumbers. All shops should sell you part of cucumber, like half cucumber or quarter of cucumber, and you should be able to eat any part of them. So we have extra scenario. And now the question is, with regular approach, when everything is a feature, we would fix this feature, add one more feature for this case. But since we suppose that this feature will be implemented by a developer without looking for the test to be done first, and tester needs to be done to have this feature implemented in most effective way. Let me do this the same way as I suggest. So suppose that we have this urgent requirement. It was implemented in the system, and I need to quickly test it. So I'm defining some additional map of data, partial cucumbers. Let's say start 8 left. So use Rapise feature here, and suppose we have 1.5 cucumber in the beginning. We ate just half of them. We don't need the whole cucumber, and we should have 1 left. And we have 2. We eat 1.5, and we should have half of cucumber left. Now, what I can do, I may just play the same implementation with this data directly without writing a feature. I may use rel to play sheet. The sheet name is rel. This one, this is the sheet of the same script. And I now need to specify the value for variables. And since I have a map, when I have a map, I may use it as a type, part cucumbers, and take the value from the start as a start. Now here it suggests other. So it suggests them here because they are declared as preamble variables with this yellow background. So I may use, I may redefine their values when calling this sheet. Part cucumbers 8 and left partial cucumbers left. Okay, so I may now play just this sheet, and since we getting not much time, I want to speed up to reduce the command interval and do right click, play this sheet. Oh, it's much faster this time. Okay, so you see the same test now executed without feature files. So I reuse this feature implementation I had before because I have it in rel, and rel is quite flexible. It's tuned for every part of it to be separately executable, and I may use it this way. So I may have old feature as a test as well as a new test reusing the same functionality, but we don't need BDD at this level. We alone. I am just a QA person. I just need to quickly test what I get, and I'm looking for the shortest way. So now, when I'm focusing on my testing framework, I have this eating feature, and I may just use again rel to play script. Script path is eating, and sheet name is not rel but partial cucumbers. So this is now a testing framework containing mix of BDD features, cucumber based, and the direct implementations. And these should be able to work all together as a part of my testing framework. And I think so. That's all about. So I'm not going to run. I'm running out of time. Let me finish the topic. So finally, the Bdd lifetime assumes that it's only the Bdd is effective while there are 3 amigas and all 3 of them are participating. With time, if like 1 or 2 amigas are left or doing something else, Bdd becomes more a headache. Also, in many cases, Bdd, like in this initial slide, also used for test management. You see it contains some comments, some text to separate data, to split which features to run and which are not to run. It's actually needed here just for test management, to quickly select which features to run. With Rapise, with Spira, there are many others ways to do real, true test management. So you don't need to add this like hardly readable and say implementation-specific things to your features. You may have them cleaner for this purpose, and you may use Rapise and Spira native features to have the same done in proper way. In later stages, it's common for Cucumber to be used just as test scripting language. And in our case, we show that you may mix. So in the beginning, you may use feature files, then you may switch to actual scripting, depending on the project situation in your project. And I believe that, so the idea that, to summarize, by having Rapise and Bdd, you get the best from two worlds, and you're preparing for long life of your project. So in the beginning, you do while you have Amigas, you do what you may do the best from the Bdd. If situation changes, if something urgent, you may reuse the same without need to keep this Bdd legacy, and without need to mimic Bdd and having the scenarios like this one, because this may be implemented much easier using just regular automation testing features. So you may do this with Rapise. I hope I was able to demonstrate it. So that's basically all of my talk for today. Thank you for attention, and I'm going to check if there are questions available. Okay, so I hope there is no more questions. Sorry guys for my silence in the beginning. It was online effect. Thank you for attending these webinars. Hope you will see on the next time. Also check out Inflectra channel. We have regular stream. They happen every Thursday on 10 a.m. AST, and you may actually participate online. You may ask your question. We will reply them online. So just go to YouTube Inflectra, and you will see this information there. Thank you for attention. Have a good day. Bye-bye.